Welcome to Escalation. In our previous videos, we went through numbers and strings from a data type perspective, understood different types of numbers and strings, all escape characters in Python, learned immutable nature of both numbers and strings. In this video, we will learn about list, one of the most used data types in Python. A list is a group of multiple items separated by a comma where the group is enclosed with square brackets. In this example, we have created a simple list of numbers separated by a comma and enclosed in square brackets. Well, we may wonder how many items of these can we fit inside a list. Python does not have a built-in limit to the length of a list. However, it depends on our hardware like memory capacity, CPU architecture, whether if it is 32-bit or 64-bit, etc. For now, let us not worry about it, but the point is, Python does not imply any limit on this. The next question that comes to our mind is, can we include items with different data types in a list? The answer is yes. For example, if I take just numbers, in a list, we can include an integer, a floating point, a hexadecimal, binary, all in the same group. Similarly, we can also include strings in this. Just for fun, let me add a smiley using a Unicode string. That's amazing. That's not it. We can include another list inside the list, tuples, sets, and all other data types that we will learn in our upcoming videos. So, we can consider that Python does not imply a data type restriction on a list. Now, how do we access these items individually for any operation? As we saw in strings, we can use index in list also. We did not talk much about indexes while exploring strings, so let us take a quick look at how index works. FYI, this concept applies to string as well. I will consider both string and a list to explain, and the functionality of indexes are same. I will take a string value, Python for beginners, and I will take a list of some random alphabets. Each character in a string or each item in a list has an index, which starts sequentially from 0 up to the count of the characters in these values. You could consider these as some sequential addresses to our characters and items. That means the address for us to get to letter F in this string is 7. Similarly, the address to get to letter G in this list is 0. Syntactically, in our script, if we create these variables, we can just use square brackets next to the name of the variable and mention the index or the address that we saw, and we can get the item or character at that index. At times, we must have to access characters the other way around, like how we have our index starting from 0 when we are going from left to right. From right to left, we have another index which is negative and starts from -1 and it goes -2, -3, etc. up to the count of the characters or items in these variables. So now, if we need to access the letter F, we can either use index 7 or -13, and it will lead us to the letter that we are looking for. It applies the same to list as well. Now let us talk about list mutability nature. But before, let us recap on numbers and strings. In numbers, we saw that when we are overwriting an existing variable, the memory location of the variable was different from the earlier. In other words, it was creating a new object instead of overwriting the existing. Similarly, in strings, we learned that the string itself will have a separate memory location, and each character in a string will be stored separately at different locations. Whenever we are trying to update an existing string, the location of the updated string was new, which means the object of the string was getting created again. However, internally the characters were pointing to the same location only if a character was also present in our variable before the update. Please do watch Strings Part 1 for detailed explanation on this. Let us see how memory location works for a list. I will create a list of characters from the phrase Python for beginners. If you notice, I am including spaces also in this list. Let us check the memory location of the list itself and for some of the items from this list by their indexes. The functionality is same as strings, where the whole list itself is pointing to one memory location and each item is stored at different locations. Let us also check if same items point to one location itself. When we see the locations of letter N, we can make sure that till now everything is same as strings. Now let us see what happens when we are updating the list. Unlike in string where we cannot update a value at a specific index, in list we are allowed to do that. Let me update the space to an underscore using the index of the first space. Now if I check the location of the list, we see that its location is same as before. Here is the difference between strings and list. And hence lists are called mutable, which means it will make updates to the same object rather than creating a new object. Here are some exercises to get you some hands-on experience. Please post your answers, questions or doubts in the comments below and I will try to address that to the best of my knowledge. We are currently looking at the data types only from the data type perspective. We will have operators and different functionalities of all data types in our upcoming videos. Please subscribe to my channel for notifications on upcoming videos.